Viscosity. In our earlier lessons, we saw how fluids behave when they are still. But what happens when they move? Just like how moving solids face friction, moving fluids experience something too. It's called viscosity. The liquid layer close to the solid is at rest because of adhesive force available between the solid and liquid. Each upper layer has little extra velocity than the lower one. Viscosity is the resistance a fluid shows to motion. It happens when one layer of fluid moves faster than another and the two layers push and pull against each other. Introduction. We studied the mechanics of fluids at rest, called hydrostatics. Now we learn fluids dynamics, the study of fluids in motion. Now we explore fluids in motion, which have potential energy, kinetic energy, gravitational energy, frictional forces called viscous forces. What is viscosity? Most fluids resist motion. Here you have a solid surface, a drop of liquid is placed on it, the drop is cut into different layers. Frictional forces occurs between fluids and a solid surface, between two layers of a moving fluid. This resistance to flow is called viscosity. Definition. Viscosity is the property of a fluid that opposes the relative motion between its layers. Viscosity is the property of fluid that opposes the relative motion between its layers. Activity to understand viscosity. Let us take three steel balls of same size. Drop them into air, water and oil. Three tall jars. The first one is filled with air, the second one is filled with water, the third one is filled with oil. We drop simultaneously three steel balls into three liquids. Observation. Ball moves fastest in air, slower in water and slowest in oil. Reason. Oil has more viscosity than water or air. More viscosity means more resistance. Cause of viscosity. Consider a fluid flowing through a pipe. Layers close to the solid surface move slowly due to adhesion. The inner layers try to speed up the outer one. The outer one tries to slow down the inner one. This creates a backward tangential force, shear stress, that causes viscosity. Newton's law of viscosity. Now, let us understand how scientists describe this. The outermost layer is with a solid pipe, so it is a fixed layer. Let us consider two layers A and B. The A1 is the outer from the axis which has a velocity v. Then the B layer has little extra velocity. We call it as v plus dv. The B layer is at a distance x. The distance between the two layers A and B is dx. The slower a layer moves compared to another, then more the resistance. The slower a layer moves compared to another, then more the resistance. The resistance or viscous force depends on two things: the area in contact, how fast the viscosity changes between layers. Viscous force between layers depends on 1. The area of contact A, the second velocity gradient dv by dx, how the velocity changes with respect to distance. So F equals minus eta A dv by dx. The constant of proportionality eta is called the coefficient of viscosity of the liquid. The negative sign shows it's a resisting force. So the formula F equals minus eta A dv by dx. Coefficient of viscosity eta. Let us take the value of eta from the given formula F equals minus eta A dv by dx. So we get eta equals F divided by A times dv by dx. Let us consider the A as 1 unit and the velocity gradient dv by dx is 1 unit. Then what we get is eta equals F. So eta measures the magnitude of viscous force per unit area per unit velocity gradient. The SI unit of coefficient of viscosity is Pascal second or Newton second upon meter square. The dimensional formula of the coefficient of viscosity is m L power minus 1 T power minus 1. Important notes. Viscosity is similar to friction. It converts kinetic energy into heat. High viscosity means thick fluids, example honey, glycerin. Low viscosity means thin fluids, example water, air. When temperature increases, the viscosity decreases for liquids but increases for gases. Remember, thicker liquids like honey have more viscosity, thinner ones like water have less viscosity. So, viscosity is like fluid friction. It resists flow and turns motion into heat. Viscosity, the internal friction of fluids.